Okay, and now we're going to finish up with a little bit more on limits. Now, just because it says the word practice here, I'm gonna say there's some new stuff in here too. So don't just tune me out and be like, I already learned it from the first part. All right, so first things first. This type of problem. Now, you might be saying, step one to doing limits, we always just substitute in our number, and you are correct, right? No matter what it looks like, whether it's square roots or just polynomials or whatever it might be, it doesn't matter. We are always going to sub in our number first, because if we substitute in 9, whatever our function looks like, I have no idea. If I'm able to just substitute in 9, that means my function's continuous. So therefore, from the left and from the right, I don't have to figure any of it out. It's just whatever I plug in, that's what I get out. That's my limit, right? So let's plug in 9 and let's see what we get. This is going to be the square root of 9 minus 3 over 9 minus 9. Now this is not looking promising because I already see that denominator is going to be a 0. Now I can't stop there, because if it's a number divided by 0, then that means we are doing big little logic to figure out if it's infinity or whatnot, because it would be a vertical asymptote. But if it's 0 over 0, then that means it's a removable discontinuity, which means it is algebra. Okay, which means we have to factor and solve, or do some kind of algebra to solve it. So we need to figure out what that numerator is. So we keep going. What is the square root of 9? Well, that's 3. And so what we can see here is this is a 0 over 0, which means we're not done. But that means we're using algebra. We need to go back and use algebra to solve this problem. Okay, so factor or something of that nature. Now, I know for a fact, because it's x equals 9, I will get a factor of x minus 9 in that numerator, because when I sub in 9 minus 9 makes 0, okay? And I mean, they get a little harder later, but for right now, I know that's going to be the case. So I've got to figure out how to factor out an x minus 9. Now, that's not obvious because of the square root. I don't know how to factor with square roots. So what we're going to do is we're going to use a technique called rationalization, or to rationalize. Now, you may remember rationalizing. That word may sound familiar back from algebra, where you had maybe something like 1 over the square root of 2, and your teacher said, look, we are going to multiply both the numerator and the denominator by the square root of 2, because the numerator would just be 1 times square root of 2, right? But that denominator, we liked multiplying by rad 2 and rad 2, because that gave us rad 2 squared, or aka rad 4, which simplified to be rad 2 over 2. Now, I'm going to propose we think about this slightly differently, because it will help us with the problem we're about to do. What I'm going to do is I want to think of it as inverse operators. I'm going to think of it this: rad 2 times rad 2 is the same thing as rad 2 squared, isn't it? Because it's something times itself. Now, a square and a square root are inverse operators, so they simplify to leave us just with whatever was on the inside. Now, you might be saying, Professor Dwork, or whichever professor you want me to be, which if you're in another professor's class, you might be saying, isn't that the same thing as what we did before? Well, yes, it is, but you're going to see how that thought process of the inverse operators is really going to be helpful in a second. All right, so we're going to go ahead and rationalize this. Now, when we say rationalize, we're looking for wherever the square root is, okay? And we're going to multiply by the conjugate. Now, this is a big word, lots of big fancy words for a very simple concept. I look at whatever this function is, I'm going to multiply by that same function, but notice the sign in between the root and the constant, that changes. If it was positive, it would become negative. If it's negative, it becomes positive. So you'll notice here, it looks identical, except it has a positive sign between. Now, I'm going to do that same thing. I can't, just like with rationalization, whatever I do to my numerator, I have to do to my denominator, and I have to keep them the same, right? And notice these are multiplying, so parentheses around everything, because distribution is going to come into play. Now, here's the fun part. I already told you, we know a factor of x minus 9 is in that numerator. So this denominator, don't touch it. Leave it factored. It already has a factor of x minus 9. I don't want to distribute that denominator or make it any more difficult. But the numerator is where the work has to occur. The numerator is where we know there's an x minus 9 factor hiding. So we're going to go get it. We're going to distribute. Now watch how this works. The square root of x times square root of x. This is very familiar with what we were just saying. That's the same thing as square root of x squared. Square root of x times 3. So this is going to be plus 3 root x. I'll switch colors here. So then this next part would be minus 3 root x. And then negative 3 times positive 3 makes negative 9. So far, so good. All right, now let's keep moving along here. Let's do some simplification. Now we already know the square root and the square are going to simplify. And notice every line I'm writing limit as x approaches 9, right? Nothing just comes and goes, right? All of this notation is required. So, okay, so now the square root and the square are going to simplify, leaving me with x. Now here's the fun part. Plus 3x minus 3x. Those subtract to make 0. And notice what I'm left with in that numerator. There's my x minus 9. And so that happens every time. When we do rationalization, every time. Okay, now down for that denominator. Do you see why we left this factored and we didn't want to mess with it and distribute it through? Because now my x minus 9 and x minus 9 divide. Don't forget, dividing, they don't cancel. They divide. And when you divide, 5 divided by 5 is 1. 7 divided by 7 is 1. X minus 9 divided by x minus 9 is 1. So my numerator is now 1. So that's going to leave us with 1 over the square root of x plus 3. And now I can substitute in my 9, right? I can now, so now notice the equal sign comes on the page, and I'm left with 1 over the square root of 9 plus 3, working vertically, which is 1 over 3 plus 3, which results in 1 over 6. Look at that. Isn't that beautiful? Okay, so going back, notice how do we do this problem? We identify where the square root is. We're going to multiply by its conjugate, both the numerator and the denominator. Now, the part where the square root was, that's what we distribute. The part where the square root wasn't, that denominator, leave it alone. Don't distribute. And then you'll get your factors to come out. All right, so we're going to do it again. We're going to do it again with a monster. Look at this thing. This thing looks horrible, and that's why I picked it, because sometimes identifying this conjugate can be a challenge. So I want you to pause the video. I want you to try to identify what the conjugate would be. But notice this is well, actually, hold on. Slow down, Professor Dork. First, we just got to plug in our number, right? If it's not 0 over 0, we don't do anything. So start by doing that. All right, so 6 minus 6 over the square root of 6 squared would be 36 plus 6 minus 17 minus 5. Okay, so the numerator is 0, but that doesn't tell me anything. 0 divided by 7, that's 0. We're done. Okay, so that's not a big scary thing, 0. But we got to work on this denominator. Okay, what is 36 plus 6? That's 42. 42 minus 7, 25. So that's the square root of 25 minus 5. So this would be 0 divided by 5 minus 5, 0 over 0. It's almost like a math professor made this up specifically so it would be 0 divided by 0. It's crazy how these things always work out in the notes. Okay, so we're going to go ahead and erase is 0 over 0. That tells us it's algebra technique. Okay, we know, because when I sub in 6, it's got to be 6 minus 6. It's got to have a factor of x minus 6 hiding in this denominator. We just got to get it out of there. So how do we do that? We look for where the square root is. We look for the square root is this function here, this denominator, and we are going to multiply by its conjugate, right? That big word that really just means switch the sign. Now, we are going to switch the sign between the square root and the constant. Square root and constant. So all the stuff under the square root, that stays the same. That's going to be x squared plus x minus 17. The 5 is going to stay the 5, right? What is the sign in between? Minus. So that's going to become plus. Okay? Whatever we do to the denominator, we have to do to the numerator, right? We have to multiply by 1. We can't do things, just willy-nilly, just to one or the other. And don't forget parentheses around everything, because it's all distributing. That's wrong emphasis on the syllable. Okay, now, what are we going to do? We're going to go ahead and distribute. Now remember, where the square root was, that's what we actually distribute. The other part where the square root wasn't, leave it factored. So that numerator this time, we're just going to leave it factored. It's going to be x minus 6 times the square root of x squared plus x minus 17 plus 5 all over. Here's where we distribute. Okay, so the square root of stuff times the square root of stuff, just remember, that's this plus x minus 17 squared. right? Okay, now square root of stuff times positive 5. So 5 times the square root of x squared plus x minus 17, right? So that's the square root times the 5. Got that part, right? So now we have to distribute the negative 5. So negative 5 times, whoops, let me use a different color. Let me switch that up to a different color that'll stand out. Let's do red. So it's going to be negative 5 times this. Okay, so let's extend this out. So this is going to be negative 5 times the square root of x squared plus x minus 17. And then we're going to distribute the negative 5 and the 5. So that will make negative 25. And here we go with our simplification. Yay, algebra, right? Everybody loves algebra. Numerator, leave it alone. We already have the factor of x minus 6. We don't want to mess with it. It's our friend. Okay, over. Now here, the reason we write this as a square root quantity squared is because they just simply simplify, leaving us with x squared plus x minus 17, right? You just copy it down. Now the next fun part. Notice these middle terms. 5 times the square root of blah minus 5 times the square root of blah. It's going to subtract to 0. That's amazing, right? Every time. Okay, that inside stuff always subtracts to 0. All right, now let's keep going with our algebra here. Notice I'm still working vertically. I'm still writing the limit as x approaches 6 on every single line. I'm still, even though I'm going to do algebra simplification in my denominator, I still have to write the numerator. Okay, now let's combine. So this is going to be x squared plus x. Let's see, negative 17 minus 25. That's going to be negative 42. All right, now we can see it, hopefully. Hopefully we're looking at this saying, I can see my factoring. Whoops, that should be minus 6. I can see my factoring. This is going to be x squared plus x minus 17 plus 5. Okay, down to the denominator. X, what times what makes negative 42? Adds together to make positive 1. Well, minus 6 plus 7. Right? 7 times 6 is 42. So there's my factoring. And this is a moment of happiness because the x minus 6 divides with the x minus 6. And I am now able to substitute in my 6. I'm able to substitute my value. This is going to give me, we already did this math. When I substituted 6 into this is going to be 36 plus 6 minus 17. That didn't change, right? The only thing that changed is this became a plus 5 instead of a minus 5. Over, now when I substitute my 6 here, it's going to be 6 plus 7. And presto changeo. I don't like that color. It's too close to the other one. Let's go to, that's the same as the other one. I can't find a good color. I have no colors. Let's go purple. All right, so this is going to be the square root of 25 plus 5 over 13. And last but not least, this is going to be 5 plus 5 over 13. So therefore, at this point, I'm hoping everybody's already ahead of me saying this is 10/13. All right. So what's the big idea? What's the big idea? Right? When you see these square roots and functions, rationalization is our technique. It doesn't matter if it's in the numerator or the denominator. We just rationalize, right? And we'll get it. All right, moving along. This problem's far more similar to the previous work we'd already done, right? So we're going to go ahead and start off by subbing in 3 halves, and of course you can use your calculator to help you verify, right? We're not looking for that you know how to substitute in values. That's college algebra skills. But what we are looking for is that you do check: is this a number over a number or 0 over 0? So I'm hoping when you sub this in, you're going to get 0 over 0. Okay, so how do we do this technique? Is this a rationalize? No, there's no square roots. So no, this is not a rationalize. This is just a polynomial over a polynomial. So we know our goal is to factor. We need to factor. All right, so I'm going to write limit as x approaches 3 halves. And now I get out to say to myself, okay, you can use whatever factoring technique you want, whether it's AC method, whether it's bottoms up, whatever you were taught, we don't care, just as long as you get the right factors. I'm going to go guess and check. Okay, I know I need to have x's and x's, right? And what times what makes 6? I know these numbers have to be relatively balanced, so I'm going to try a 2 and a 3, and then I'm going to try putting maybe a 3 and a 2, and let's see how this works out. Because 3 times 2 makes 6. Now I know one of them needs to be negative, one needs to be positive. So let's see what happens here. 2x times 3x, that makes 6x squared. Good. Okay, 2x times negative 2, that would make negative 4, well, right here, negative 4x. And then working the insides to get the other ones, this would be positive 6x. So when I add those together, that's not going to work. All right, so let's try. What can I do? Let's try swapping. Oh, because that's not 6, that's 9. I'm like, this should be working. There we go. 3 times 3 does not make 6. 3 times 3 makes 9. Yay, good save. Okay, now, what's the issue? 9 minus 4, right? Because it would be 9x minus 4x. That would not make negative 5x. That would make positive 5x. So, easy flip, easy switch. All we do is we say, instead of, I just have to flip my signs. So now, the 2x and the 2 will make positive 4, and the negative 3 and the 3x would make negative 9. Now when I add them together, I get negative 5x. So notice this is now going to work because the 2x times 3x makes 6x squared. My 2x times 2 and my negative 3 times 3x makes negative 5x. And then last but not least, negative 3 times 2 makes negative 6. There's my guess and check technique for factoring that down to the denominator. I will guess and check that one as well. This is even easier because I know it's a 2. So therefore, I know it's got to be a 2x and an x. What times what makes negative 12? Well, I'll give you a hint. I know I've got to have a match. So I'm going to take a guess and say my 2x minus 3 is going to match with my 2x minus 3 because I know it's got to have a factor. That when I sub in 3 halves, I get out 0. So I'm going to guess it's this. Let's check it now. 2x times x makes 2x squared. 2x, let's do our outsides. 2x times 4 makes 8x. Insides would be negative 3x. When I add those together, I get positive 5x. They are a match. And last but not least, negative 3 times 4 is negative 12. We have successfully factored. Yay, factoring! Okay, so then this divides with this. And now I'm able to sub in 3 halves. And this is not going to be a pretty number, and that's okay. 3 times 3 halves plus 2 over 3 halves plus 4. All right. Well, we keep our answers exact unless the problems say round. So this is going to become fractions. This is going to become 9 halves plus 2 over 3 halves plus 4. Okay, now what? Well, common denominators, right? If we're going to add fractions, we need common denominators. Please don't tune me out. This is going to actually be really important for the next problem we do. So this is a quick little refresh of common denominators. Okay, so to add fractions, right, this would be the same thing as 2 over 1. It needs to be, I look at the numerator individually. I say, okay, the other one has a denominator of 2, so this one needs a denominator of 2. But I can't just change the denominator. I have to change the numerator as well, right? I have to multiply by 2 over 2. And then same thing for the denominator down here. This would be 4 over 1, so I have to multiply by 2 over 2 to get it a common denominator. So this is going to give me 9 halves plus 4 halves divided by 3 halves plus 8 halves. Okay, now what? Now what? All right, moving right along. Let's see. Because we have the common denominators, we can now combine them. We can now add them. So this is going to be 13 halves divided by 11 halves, okay? Last but not least, we're going to think of this fraction line. If it helps you, we're going to think of this fraction line like division. We're going to say this is the same thing as 3 halves divided by 11 halves. And now that we read it this way, hopefully you're seeing, how do we divide fractions? Not with a keyboard. How do we divide fractions? You change, keep, change, flip, or flip and multiply, whatever you learned. And now the 2 divides with the 2, leaving me with 13/11. All right. Hopefully we all remember how to add and subtract fractions now at this point. Because, oh my goodness, I'm going to use as much space as I can. This problem I have a feeling is going to take up a lot of our paper, so I'm going to kind of section it off and be like, we're going to maybe need some space. All right. What do we notice about this problem? Oh my goodness, fractions. Now, step number one, substitute in the number one. If it gives you a number over number, you're done, right? So let's just hope and pray. All right, so if I substitute in one, this is going to be 1 over 7 minus 1 over 1 plus 6 over 7 minus 7 over 1. Not looking good. Okay, because now we're going to have 1 over 7 minus 1 over 7 minus 7. Sad face, right? This is 0 over 0. But the good news is we know because it's 0 over 0, this is algebra. This is an algebra technique. This is not big little. We are going to have to solve this using college algebra. All right, wish us luck. Wish us luck. Now, this is not a rationalize because there's no square roots. It is not a factor and simplify because it's not a polynomial over a polynomial. This is fractions. So this we call the common denominator. We're going to solve this by getting common denominators, right? We're going to do what we literally just did over here when we added and subtracted our numbers, right? We said we need common denominators. So we looked at this denominator and said, what does this one need? It needs a 2, right? So we're going to go back and do that here. We're going to look at this and say, this denominator has a 7x. Multiplication. We're looking at factoring. Does this one have a factor of 7x? Nope. So we give it 1. We're going to, let me change colors on this. So we're going to give it 1. We're going to say this is going to be times 7x. Whatever I do to the denominator, I have to do to the numerator as well. So now this denominator here, I'm going to highlight it in green, is 7x times x plus 6. The one we're trying to add it to, the one that's in yellow, does it have an x plus 6 factor? No, it does not. So we need to give it 1. We're going to give it an x plus 6. Whatever I do to the denominator, I have to do to the numerator, right? And this is all factoring, so it's all multiplying. Now they would match because this one on the left, this new denominator would be x plus 6 times 7x. And on the green one, it's going to be x plus 6 times 7x. They're going to match. So that's the numerator. Now let's do the denominator. Now notice this 7, whenever it's just a constant or whenever it's just a value, it's over 1. So we say this, we don't have to worry about factors of 1, but we do look over here and we say this one has a factor of x. So I have to give this one a factor of x, right? An x in the denominator. So now the denominator will be x on both of them. Let's rewrite this to make it a little cleaner, just to make this a little easier to follow. We're going to say this one on the numerator on the left-hand side is going to be x plus 6 over x plus 6 times 7x minus, now the numerator is going to be 7x over x plus 6 times 7x all over, I'm going to rewrite these in order, so I'm going to write as 7x over x minus 7 over x. So far, so good. Please notice, limit as x approaches 1 is written off to the left-hand side. As always, does not go away until we are able to substitute in that 1. Still can't substitute it in. It will give us 0 over 0. So we keep going. Now, how do we add fractions? When they have common denominators, the denominator stays the same, right? Let me go back over here, right? When I added the 9 halves and 4 halves, the denominator stayed the same. It stayed as halves, just the numerator's added. 9 and 4 makes 12 or 13. So here, we're going to keep our denominator the same. So it's going to stay x plus 6 times 7x. The numerator, watch this minus sign. If this had more, we'd have to distribute it through, right? It's minus the 7x. So just be mindful of that. So I'm going to write it very carefully. We're going to write as x plus 6 minus 7x. Now, we don't need the parentheses because there's no adding or subtracting, but if there were, we would have to distribute it. Okay, same thing for the denominator. It's going to be, the denominator will just be x, and the numerator would be 7x minus 7. Now, combine your like terms, right? So we'd say this is going to make negative 7x. I'll just kind of rewrite it like that. And so now we're going to say, all right, limit as x approaches 1. X minus 7x would make negative 6x plus 6 all over x plus 6 times 7x all over, and let me scoot this over here because I really want it to be clear that it's on the left-hand side. There we go. All right, now this denominator, there's really not much to do, so we're going to leave it as 7x minus 7 over x. Okay, so far so good. Now, Now we're ready to flip and multiply. Now we're ready to think of this big old long division sign as an actual division sign, right? So we're going to write it like 6x plus 6 over x plus 6 times 7x divided by 7x minus 7 over x. Almost there. Now we change that to multiplication. We keep, change, flip, or flip and multiply, whatever you like. Times x over 7x minus 7. Now, the trick to this is you might be looking at this saying, oh, look, because of the multiplication, I know, right, these are going to multiply, right, everything gets parentheses, right, it's x times all of that, so I know this x and this x will divide, which is true, right, but that's not going to fix our problem, because when I sub in 1, I'm still going to get 0 over 0, so let's factor, right, so other than these x's dividing, let's also factor. Notice here in my numerator, I have 6x plus 6, negative 6x plus 6. Let's factor out the greatest common multiple. Let's factor out a negative 6, which will leave me with x minus 1. Then in my denominator down here, this x plus 6 I can't touch. That 7 is still there. And then out of, I'll highlight this in yellow, the 7x minus 7, we have another factor of 7 we can factor out, leaving me with x minus 1. And right there is my magic moment. Because notice, if I sub in 1 into here, that would be 1 minus 1, which makes my 0. But my removable discontinuity just got removed. The division, the magic of division occurred. And now I'm able to substitute in my values. I'm going to write it out. You don't have to. In my class, you could sub in your value here. But I just want to make this as clear as possible that we had 2 7s, right, multiplying. We had one that factored out from here, and we had one left over from our denominator. So that's actually going to be 49 x plus 6 down here. Okay, and now I'm going to substitute in my 1. And so now notice that's where my first equal sign appears on the entire page. And I'm going to say this is 49 times 1 plus 6. So therefore, this is going to be negative 6 over 49 times 7. And pardon me, I've got to grab a calculator. I don't know what 49 times 7 is, although I probably should. 343. Okay, so this is going to be negative 6 over 343. And there's our limit. So remember, what does this tell me? This tells me the y value that the graph is approaching as we approach 1 from both sides. From the left and from the right, the y value would be this. And that's the exact value. No decimals, no numbers coming out of the calculator. This was all algebraically done by hand with the exact value of negative 6 over 343. Okay, so hopefully, let's just recap really fast. Hopefully, this helped clarify some limits concepts. When you see square roots, square root plus or square root minus, that is a conjugate problem. Again, all of these were 0 over 0, right? All of these where you sub in the number, you get 0 over 0. If you see square roots, multiply by the conjugate. Multiply by the conjugate. If you see polynomials, those are usually just factor, right? Factor the numerator, factor the denominator. And if you see fractions, let me clear this up. If you see fractions, common denominators, get them to a single fraction, right? Get them so it's a fraction, a complex fraction, fraction divided by a fraction, flip and multiply, right? And that will get you a new look. And then we went back to factoring, because once we did that, we had polynomial over polynomial, so it became a regular factoring problem. All right, hopefully this helps clear up some limit concepts and helps you get you on your way.